NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve logarithmic equations by converting them to exponential form. We'll use the key rule, log base a of f of x equals b if and only if f of x equals a to the power b. We'll apply it to several quick examples and check domains. Before using the rule, remember the conditions. The base must be positive and not equal to 1, and the argument of the logarithm f of x must be strictly positive. Example, problem 1. Log base 2 of the absolute value of x plus 1 minus 2 equals negative 2. First, convert from logarithmic to exponential form. That gives absolute value of x plus 1 minus 2 equals 2 to the power negative 2. Next, use the negative exponent rule. 2 to the negative 2 is 1 over 2 squared. Now isolate the absolute value. Add 2 to both sides to get the absolute value of x plus 1 equals 1/4 plus 2. Combine the numbers. 1/4 plus 2 is 9/4, so absolute value of x plus 1 equals 9/4. Solve the absolute value equation by splitting into two linear equations. X plus 1 equals 9/4 leads to x equals 5/4, and x plus 1 equals negative 9/4 leads to x equals negative 13/4. Finally, check the domain of the original logarithm. The inside must be positive. Both values make the inside 1/4, which is positive, so the solution set is negative 13/4 and 5/4. Example, problem 2. Log base 2 of quantity x squared minus 6x equals 3 plus log base 2 of 1 minus x. Bring the logarithms to the same side. We obtain log base 2 of x squared minus 6x minus log base 2 of 1 minus x equals 3. Use the quotient rule of logarithms. We get log base 2 of the fraction x squared minus 6x over 1 minus x equals 3. Convert to exponential form. The fraction equals 2 to the third power. Evaluate 2 to the third as 8 and clear the denominator. That yields x squared minus 6x equals 8 times quantity 1 minus x. Then x squared minus 6x equals 8 minus 8x. Move all terms to one side to form a quadratic x squared plus 2x minus 8 equals 0. Factor. The product is x plus 4 times x minus 2 equals 0, giving potential solutions x equals negative 4 and x equals 2. Check the domain. 1 minus x must be positive, and x squared minus 6x must be positive. Only x equals negative 4 satisfies both, so the solution is x equals negative 4. Here is the problem statement. We begin with the equation x to the power log of 2x equals 5. Step 1. Take the logarithm of both sides. This gives log of x to the log. 2x equals log 5. Step 2. Apply the power rule for logarithms. The exponent multiplies in front. Log 2x times log x equals log 5. Step 3. Expand log of 2x using the product rule. Then introduce the substitution log x equals y. Step 4. Substitute y for log x. Step 5. Distribute and rearrange into quadratic form. Step 6. Apply the quadratic formula to y and simplify log 5 using change and difference of logs. Say, log 5 equals log 10 minus log 2, which is 1 minus log 2. Step 7. Substitute 1 minus log 2 for log 5. Step 8. Expand the term under the radical and recognize a perfect square log 2 for log 5. Step 8. Expand the term under the radical and recognize a perfect square. Step 9. Take the square root of the perfect square. Step 10. Evaluate the two cases for y. First, choose the plus in front of the parentheses. Minus log 2 plus log 2 minus 2 all over 2 gives negative 1. Second, choose the minus in front of the parentheses. Minus log 2 minus log 2 plus 2 all over 2 equals 1 minus log 2, which is log 5. Step 11. Recall that y equals log x base 10. Convert back to x for each case. Therefore, the solutions that exactly match the image-based workflow are x equals 1/10 or x equals 5 base 10. Convert back to x for each case. Therefore, the solutions that exactly match the image-based workflow are x equals 1/10 or x equals 5. Show the problem statement. Now method 1. Create the method 1 panel. First step, Rewrite 1 as log 10. Combine logs using the product rule. Use the one-to-one property to drop logs. Collect x terms. Solve for x. In this lesson, we will solve the equation x to the log x equals 10 to the 2025 using two clear methods that mirror a typical textbook solution. We will also keep an eye on the domain. The logarithm of x requires x greater than 0. Method 1. Take the common logarithm of both sides and simplify. We first apply logarithms to both sides. Then use the power rule of logarithms. Log of a to the b equals b times log a. Since log 10 equals 1, we obtain log x squared equals 2025. Recognize 2025 as 45 squared. Therefore, log x equals plus or minus 45. And converting back to exponential form, we get the two solutions. To build intuition, think of y equals log x. On this number line for y, the two values are minus 45 and plus 45. Mapping back with x equals 10 to the y sends minus 45 to 10 to the minus 45, a tiny positive number, and plus 45 to 10 to the 45, a huge positive number. Method 2 mirrors the same logic with a substitution. Let y equal log x, so x equals 10 to the y. Substitute into the original equation, x to the log x becomes 10 to the y. Combine exponents using the power of a power rule to get 10 to the y squared equals 10 to the 2025. With equal bases, set exponents equal. Y squared equals 2025. So y equals plus or minus 45, and substituting back gives the same two x values. In conclusion, the solutions are x equals 10 to the 45 and x equals 10 to the negative 45. Both satisfy x greater than 0, the required domain for the logarithm. We will reproduce the solution step by step, exactly in the same order and structure as the algorithm shown in the image. Step 1. Start with the given equality. Log base e of quantity x squared plus x equals log base e of x squared plus log base e of x. Step 2. Combine the two logarithms on the right using the product rule. That gives log of x squared times x. Step 3. Simplify x squared times x to x cubed. So we have log of x squared plus x equals log of x cubed. Step 4. Since natural log is one-to-one on its domain, equate the arguments. That yields x squared plus x equals x cubed. Step 5. Move all terms to one side. X cubed minus x squared minus x equals 0. Step 6. Factor out x. We get x times the quantity x squared minus x minus 1 equals 0. Step 7. From the factorization, we have a system. X equals 0, or x squared minus x minus 1 equals 0. Solving the quadratic with the quadratic formula gives x equals the quantity 1 plus or minus square root of 1 minus 4 times 1 times negative 1, all over 2. That simplifies to x equals 1 plus or minus square root 5 over 2. Final acceptance step, exactly as shown in the image. The accepted answer is x equals 1 plus square root 5 over 2. In this example, we will solve the exponential logarithmic equation step by step, exactly following the sequence shown in the provided solution. Step 1. Introduce the substitution. Log of x equals y, which implies that x equals 10 to the power y. Step 2. Restate the original equation and substitute x equals 10 to the y. X to the log 25 plus 25 to the log x equals 10. This becomes left parenthesis 10 to the y right parenthesis to the log 25 plus 25 to the y equals 10. Step 3. Use the power of a power rule. We get 10 to the power y times log 25 plus 25 to the y equals 10. Step 4. Apply the logarithm power rule. Replace y times log 25 with log of 25 to the y. Also define z to equal 25 to the y. Step 5. Use the key identity a to the log base a of n equals n. Therefore, 10 to the log z becomes c. So z plus z equals 10. That gives 2z equals 10. Step 6. Solve for z and connect back to 25 to the y. Z equals 5. Since 25 to the y equals z, we have 25 to the y equals 5. Step 7. Rewrite 25 as 5 squared and equate exponents. That is 5 to the 2, y equals 5. Hence 2y equals 1, and y equals 1/2. Final step. Back substitute to find x. X equals 10 to the y. So x equals 10 to the 1/2, which is the square root of 10. We will solve this logarithmic equation using a clean, step-by-step, telescoping approach that exactly mirrors the algorithm shown on screen. Here is the given equation. We are working with common logarithms, so base 10 is implied. Step 1. Add logs by turning the sum into a single log of a product. This is the product rule of logarithms. Step 2. Recognize that this product telescopes. Every middle factor cancels, leaving only 1 in the numerator and n plus 1 in the denominator. Step 3. Convert the logarithm to its exponential form. Log of a equals -2 means a equals 10 to the power -2. Step 4. Evaluate 10 to the power -2, which equals 1 over 100. Now solve the simple equation for n. Therefore, the solution for n is 99. We'll present it as a set to match the original solution format. In this lesson, we'll solve a trigonometry and series problem step by step. The equation is an infinite geometric series set equal to 2/3. We'll identify the first term and the common ratio, apply the sum formula, solve for the ratio, turn the logarithm into an exponential equation, and then solve for the angle x on the unit circle. First, recognize the left side is an infinite geometric series. The first term, a, is 1. The common ratio, q, is log base 2 of sine x. For the sum to exist, the absolute value of q must be less than 1, and the argument of the logarithm must be positive, so sine x must be greater than 0. Use the infinite geometric sum formula. The sum s infinity equals a divided by 1 minus q. Plug in a equals 1, and q equals log base 2 of sine x. Now set this equal to 2/3 and solve for the ratio. 1 over 1 minus log base 2 of sine x equals 2/3. Cross multiply and rearrange to isolate the logarithm. You should find that log base 2 of sine x equals -1/2. Convert the logarithm equation to exponential form. Sine x equals 2 to the power -1/2. That simplifies to 1 over square root of 2, which equals square root of 2 over 2. Let's visualize this on the unit circle. We'll draw a unit circle and highlight the angles with sine equal to square root of 2 over 2. Those reference angles are pi over 4 in quadrant 1 and 3 pi over 4 in quadrant 2. Now, write the general solutions. When sine x equals sine of pi over 4, the solutions are x equals 2k pi plus pi over 4, or x equals 2k pi plus 3 pi over 4, where k is any integer. Finally, check the conditions we stated earlier. Sine x equals square root of 2 over 2 is positive, so the logarithm input is valid. And the ratio equals -1/2, whose absolute value is less than 1, so the infinite sum is valid. Therefore, the complete solution set is all angles of the form 2k pi plus pi over 4 and 2k pi plus 3 pi over 4. In this example, we will solve a trigonometric logarithmic equation step by step, keeping the exact order of steps shown on screen. Step 1. Start from the given equation. Step 2. Use the product rule for logarithms. The sum of logs equals the log of the product. Step 3. Recognize 2 sine, x times cosine x, as sine of 2x. Step 4. Convert from logarithmic form to exponential form with base 10. Step 5. 10 to the power 0 equals 1. To visualize y sine equals 1, look at the unit circle. Sine corresponds to the vertical coordinate, which reaches 1 at an angle of pi over 2, and then repeats every 2 pi. Step 6. Write the general solution. The angle 2x must equal 2k pi plus pi over 2. Step 7. Divide both sides by 2 to solve for x. Finally, present the solution set exactly as written. Problem. Solve for x. Step 1. Determine the domain. The argument of every logarithm must be positive. From x minus 9 greater than 0, we get x greater than 9. From 2x minus 1 greater than 0, we get x greater than 1/2. Combined, the domain is x greater than 9. Step 2. Apply the power rule of logarithms. 2 times log of something equals log of that something squared. So 2 log of square root of 2x minus 1 becomes log of square root of 2x minus 1 squared. Step 3. Simplify. The square of a square root returns the inside. Therefore, log of the square root squared becomes log of 2x minus 1. Step 4. Use the product rule. Log of a plus log of b equals log of a times b. Combine the two logs into a single logarithm. Step 5. Convert the logarithmic equation to an exponential one. Log base 10 of a quantity equals 2 means the quantity equals 10 squared, which is 100. Step 6. Expand the product and move all terms to one side to form a quadratic. Step 7. Factor the quadratic. 2x squared minus 19x minus 91 factors as left parenthesis 2x plus 7 right parenthesis times left parenthesis x minus 13 right parenthesis equals 0. The solutions are x equals negative 7 over 2 and x equals 13. Step 8. Check against the domain requirement x greater than 9. Negative 7 over 2 does not satisfy the domain. 13 is greater than 9, so it is valid. Therefore, the solution set is the single number 13. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.